Hey guys, and welcome to my solving logs and exponentials videos. Kendall talked me into it. Well, I don't know. I just felt bad for you guys. So I'm going to give you a video. We're going to go over some stuff. We're going to kind of hit all the main ideas. The key for your study guide is online. I'm not going to go over your study guide. I'm not going to do it. We did it in tutoring today. We did it in class. Go look at it online. If you have specific questions, you may take a picture of it and send it to me via GroupMe or email. I'll be available. So, this first video, we're just going to talk about converting. Let me put my iPad down so I can actually write. Oh, sorry. Woo, let's try it again. That was bad. Okay. Converting exponents and logs, okay? So, you need to understand how to convert for the sheer purpose of you can't solve if you can't convert, all right? So, converting was the first thing we learned. We know that logs and exponents are inverses of each other. Exponents obviously will give you a certain number. Well, logs will tell you how many exponents you need to get that certain number. So, that's why we can go backwards, all right? And work in between the two forms. The first form will just do log of any base, okay? And we'll say the parentheses is always your argument is equal to, again, logs tell you the number of exponents, okay? So when we go to convert this to exponential form, well, you know an exponent has to have a base. So the base is going to stay the same. I'm going to take that exponent and put it where it's supposed to be. And it's all equal to my argument. Okay? That's how you would convert. Now, we have other logs, and we have a common log, which means we simply just have this. Log x equals y. Now, if there is no base, a common log says there is an understood 10. Okay? We simply do not write it. We don't have to write it. We know it's 10. But we do need to know it's 10 when we convert. So 10 to the y equals x. And that's how you would convert a common log. Now, last but not least, your favorite, a natural log. Okay? A natural log has a base of e. So instead of I'm yelling into the thing. Instead of using log, we will use ln. Okay? ln, this is going to be your argument. This will be equal to, I got a new pen, you guys, so I'm trying to get used to it. Your exponent. ln, your argument is equal to your exponent. Okay, so that means when we go to convert it, we now have to understand, like common log, we have an understood base of e. You guys, e is an actual number. It is like pi. You know how pi is 3.145, whatever? It goes on and on forever. The same thing with e. E is a special number. It's 2.798, something like that, okay? They're numbers. There's an actual value behind e, okay? So e to the exponent is equal to your argument. They're all the same. It has the same idea behind every single one of these forms. That is how you'll convert. So let's try another question. Let's try some examples of this. Okay, here are some examples that we're going to go through. Let's start with number 1. Number 1, we go through and we notice that it has a base of e, okay? So that means we have to use natural log to convert. So what we'll do is ln, your argument is right here. Remember, logs tell you how many exponents we need. So the ln of 12 is equal to 3x. We're just converting, we're not solving, so we're going to leave this answer as is to convert. Number 2, it has no base. Well, what is that understood to be? It's understood to be 10. So when we go to convert it to exponential form, it'll be 10, your argument, to the t power equals, excuse me, that's your exponent, 4w. Did it switch? Yeah. All right, number 3. Base is 6, exponent is x, and your argument is z. Number 4 is an exponential form, so we need to write it in log form. They give you a base of 6, so we can go ahead and write that out. Log base 6 of 12 is equal to 3x. Again, we're not solving, so that's simply all we are going to do with our solutions. Every single one of them we flip-flopped. Flip-flop. Okay? And our bases, we had to make sure we had the right bases, or we had to make sure we had the right natural log or common log. Okay? That's converting.